Hello there, I'm your host Dan Rojas, and I have some alternators here. A lot of people want to know why not just take a car alternator, hook it to a Stirling engine, a stationary bicycle, or a wind turbine and generate electricity that way. Car alternators have pulleys on them that are usually smaller than the pulley system in your car. The smaller the pulley, the higher the RPM. Car alternators require a lot of RPMs. Car alternators have very thick wiring, having the ability to produce a higher amperage. Compared to what we did in the previous video, this wiring is thinner. It would be able to handle a lower amperage, but there is more wire here. Thicker wire means less turns because it takes up more space. Thinner wire means you can put more turns around your stator. This increases your voltage at a lower speed, a lower RPM. Car alternators have access to an enormously high RPM, so much so that if you put permanent magnets in a car alternator, in a matter of minutes, it would overcharge your battery and burn your battery up, burn your whole car electrical system up because there's no way to control the RPM to the alternator. The alternators, they don't have clutches that go on and off. If they did, they'd wear out really fast. So what car companies do, they make this an electromagnet. By increasing the current that goes to these poles, you increase or decrease the magnetic field. With no load on the alternator, no magnetic field excited in the rotor, these spin almost freely like nothing. If they are new, they have a good bearing, they don't put any load on your car at all. If we energize this, I'm gonna hook these two wires out here. That's what this copper part's for. The brushes sit there to enable a current to go to that while it spins. If you hooked wires to it, they would spin around one time, rip them off, and your alternator would be done. So that takes care of getting the current to the rotor in this. Now what I'm gonna do is test this. Okay, you're gonna notice that this screw is not sticking to that. If I excite the core, if I excite the rotor, the screw sticks to it. It becomes an electromagnet. So the more current that you put to this, the more magnetic field you create, and the more power your alternator has the ability to output. If you look, I have a rare earth magnet here. I'm going to put it way over here, and you can see that the magnetic field is actually pulled it right out of my hands simply by energizing the rotor. The reason that car companies do this is to control the current going to the system in your car. If you're driving down the interstate at 2,000 RPM, this could be spinning anywhere from 4,000 to 6,000 times a minute. If these were constantly energized, it would overcharge your battery and burn your system up. If you're stopped at a traffic light, your car is idling at 700 RPM, this is going at about 2,000 RPM. You turn your lights on, flip your high-powered stereo system on, flip the blower on for your air conditioner, the electrical system gets a tremendous load. Put your windows down, lock your power lock doors, all of that causes the electrical system a higher amp load, so the alternator increases the magnetic field at the same engine RPM. This is under the hood of my car, and this is the power steering pulley right here. It is about the same diameter as the pulley, which you probably can't see because it's dark down there, that comes out of the engine. That is what determines your RPMs that shows up in your car. This right here. This is not how many times your wheels are turning. This is what the engine is rotating at. The diameter of the power steering pulley is larger. If you look at the diameter of the pulley for the alternator, it is small. It is about a third of the diameter. The smaller the diameter of your pulley in a system like this, because it's smaller than the pulley that comes out of the engine, it is about a 2 or 3 to 1 ratio. So for every RPM that your engine turns, this is going to turn about 3 times. So if you're idling at 500 or 600 RPM, your alternator is actually going to be turning at 1800 RPM. If you crank it all the way up to, say, 5000 RPM, your alternator is going to be doing 15,000 RPM. So what I'm going to do is take this. I'm going to try to keep my fingers away from all the belts and everything, and I'm going to show you the difference just with the car idling. So we're in park, the emergency brake is up so I don't run myself over by accident. And we're going to let the RPM settle back down. and we are at about 1,000. So first we're going to do the power steering pulley. You notice you can actually see that the tape on there. I got the camera strap out of the way so it doesn't get dragged down in there. And we're going to do the test. So it is, the car is idling at about 800 RPMs right now because the pulleys are very close to the same side. So 800. We look over here at our alternator. We're at 1826. So our alternator at an idle is doing 1826 RPM. Since I can't be at two places at one time, when you do that, everything in there is going to increase accordingly. I want you to watch the RPM. I'm going to turn the lights on. So this is our RPM with the lights on, off. So just the lights put a tiny drag on the motor. Denise is coming, so I'm going to have her rev the engine to 2,000 RPM, and we're going to get a test.
What's going on?
Oh, we're doing some RPM tests. I want you to just step on the gas. Rev it to 2,000. Stop. So you can see that that's pretty close to what the engine's RPM is. Now we're going to do 2,000 RPM for the engine and see what the alternator does. 2,000. So you can see that our alternator spins at a very high RPM. Wind turbines don't have access to that. Also, energizing these can be kind of a pain with your alternative energy project because you always need a current to go to these, and it requires some power. It's better to have permanent magnets there. So you can take and replace these with permanent magnets, and you can get a charging voltage out of these. The problem with that, it's a pretty complex process. You can buy them pre-made off the internet. You're still dealing with thicker wire. So this requires a higher RPM. That's why in my opinion, it's better to buy one that's custom designed for it with a lot more wiring to create a higher voltage at a lower wind speed or RPM speed. By the way, these need to go back down in there. You can see this one got broken through the process, but these pop down in there like this, and that spring has to be under there. Now you can put them down there like that pretty easily. When you have the spring in there, you're gonna see a hole that goes all the way through right there. That is where you put a little pin. I have a small Allen wrench that actually goes right through that hole. And you start with the back one. We're gonna put this back one in first here. Put the spring in, and you line it up and push it down. Now it pushes down. I know you can't see it because my hand's in the way, but I stuck this pin in there, and you notice that that back one is down there now. So now you put your next spring in, and the front one's a little bit easier. You want your wire turned the right way. Got the spring there. You push this down. The back one's harder because you have to reach deeper in to get it. But there it is. That's what you want right there. So that holds them in place. So if you were to pull this pin, they would both shoot out like a little spring-loaded thing. So then you take your rotor, and you want to make sure that this rod does not come out, and you don't want it sticking out too far. It's going to bang into the back of this. So you want it to be flush to that. And real gently, so you don't knock it out, you line everything up and put this back together the way that it was supposed to be. 4th screw. So once all of our screws are in, this little rod, you're gonna hear a click. And now those brushes are on there. So if I were to energize this, they would be transferring the electrical current to the rotor and creating a magnetic field. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos.